Hi everybody, in this video we are going to be talking about unit 16.1.1 roots. And it's just where we're going to be working on taking the square roots of things and of certain numbers, and then we're also going to work on simplifying them in case they're not a perfect square. So first, just looking at some of our terms. What our first term is going to be our radical symbol. So our radical symbol, and it's just going to be the symbol for taking a root of a number, right? So it's the radical. It looks like that. So you know, I might say, where's your radical symbol? Take the root of something, and that's what I'm referring to. The next term is going to be our radicand. So that's a D, our radicand. And it's going to be the number under the radical. So here, if we've got this and we're taking the square root of 16, our radicand is that number 16 there. Then our next term is going to be index. Index, and it's the root that you're taking. So typically, if we saw something like this, the square root of 16, it's just an implied, we're taking the square root, right? We're taking the second root of it. So we're saying what number times itself gives us 16, and you would say 4. If, however, I gave you something like this, and I said I wanted you to take the third root of 8, the 3 here is going to be written in, and again, that's going to be your index, that number that's written in there. Our next term is going to be our principal root. And the principal root is going to be the positive root of a square root. So if it's already contained, if the radical is already contained within a problem, the square root symbol, it indicates or it means that you should be finding the principal root. I guess I'm supposed to write positive here, not principal. It means that you should be finding the positive root. So here's the difference. If you were given this example, and I said, take the square root of 100. If that square root symbol is already in the problem, it's asking you for the principal root, the positive root, which is going to give you 10. If, however, you were given this example, x squared equals 100, and I said solve for x, you would go through and you would take the square root of both sides, and when you're inserting the square root into the problem, you have to account for both the positive and the negative versions of that answer. So x could equal both plus or minus 10. So you could write x equals 10 or x equals negative 10 for that one, because negative 10 times negative 10 is going to give you 100, and 10 times 10 would also give you 100. And so that is why it would give you the plus or the minus 10 for that. So then here's our rule. This is the square root of a product rule, and we're going to use this quite a bit today. So if we have something that's the square root of a times b, we can also break that up into being the square root of a times the square root of b. And where that comes in handy looks like this. So let's say we were taking the square root of 32. So we can break the square root of 32 into like the square root of 8 times the square root of 4. And just kind of taking this step by step. So I'm actually going to break the 8 down even further. And I'm going to say, I'm actually going to break that down into the square root of 4 times the square root of 2. So that's what this one is, times the square root of 4. And that second square root of 4 is just this one being dropped down. Well, what's the square root of 4? The square root of 4 is 2. So the 2 is going to come from this square root of 4. And then I'm dropping down just the square root of 2 from what we already have. And then my second one is, what's the square root of 4? And the square root of 4 is 2. So now let's simplify that. So what you're going to take is 2 times 2, which is 4. And it's going to be 4 rad 2 is your final answer. Well, here's a trick for you, just to make sure that you're simplifying your square root correctly. What I would like for you to do is to put in your calculator the square root of 32. Like put in, so in my simple calculator, I'm going to put in the number 32 and I'm going to hit the square root button. And we should already kind of know what that's going to be in between, right? So like 5 times 5 is 25, 6 times 6 is 36. So my number, because it's 32 underneath that radical, is asking the question, what number times itself will give you 32? And it's going to be in between, somewhere between 5 and 6, right? Closer to 6. So I'm going to say like 5.8 something is my guess. So let's do 32, and we're going to hit the square root button. And I was a little off, so it's 5.65 for that one. So now what I want you to do, so I'm just going to kind of jot it down, 5.65, and it keeps going. So now what I want you to do is go ahead and go do 4 times the square root of 2. So in my simple calculator, I'm doing the 2 first, then I'm hitting the square root button, and then I'm multiplying that by 4. And guess what? You get the same exact decimal, 5.65. Well, why that's helpful is because maybe you stink at this, and maybe you stink at simplifying square roots. This is a way for you to check that this answer at the end is the correct answer of simple, like the simplified version of what you started with, because you're getting the same decimal, right? That's a way for you to check your work. So let's look at the next portion of this. So it says, taking the square root of a negative number for any number a less than 0. So that means a is negative, right? Keep that in mind. So if we have the square root of a, so think about what that means. That means we've got a negative number underneath the square root. Our answer to that is going to be I square root of whatever the positive version is of a. So what does that look like? That looks like this. If we have the square root of negative 2, let's apply what we just wrote there. So if we have the square root of negative 2, that means an I is going to come out from underneath the radical, and we're going to have the square root of positive 2 there. Well, how the heck does that even work? Well, this is your very brief introduction into complex numbers. And a complex number is defined like the definition of I. So I equals the square root of negative 1. And that's what you need to know. So I is equal to the square root of negative 1. So if you have a negative underneath that radical, you're going to pull that negative out, and you're going to put an I there in your answer. All right, so here we go. We're going to look at this chart. The square root of 4 is going to be 2. The square root of negative 4, just think about what is the square root of 4? It's 2, but we also have a negative in there. So you can even think of it as the square root of negative 1 times the square root of 4. Well, the square root of negative 1, I already told you, it's I. The square root of 4 is 2, so our answer is going to be 2I for that one. This one, look where the negative's at. The negative's on the outside of the radical. So this one's going to be negative 2, because you're taking the square root of 4, which is 2. And then for our next one, it's square root of 5. Do we have an exact answer for square root of 5? And the answer to that is no, it's going to be square root of 5. All right, what about the square root of negative 5? It's going to be I root 5. And then the last one is going to be negative root 5. We just leave it like that. If you're wanting to see your intermediate step in here, that's because we're taking the square root of negative 1 times the square root of 5. And we know the square root of negative 1 is I. All right, so now we're putting these two together. So look at what we did over here, and we're putting them together right in here. So in this top one, we've got square root of 5, which is going to stay there. We've got the square root of negative 4, and we know that the square root of negative 4 is 2I. So that's what's going to come here. So then, well, what's the square root of 20? Well, we're going to break it down into the square root of 4 times the square root of 5, which is going to give us 2 rad 5 for that. So this is the same, look at this one. This is the same as we had up here, except there's a negative on the outside. So this one's just going to be negative 2I rad 5. And then our square root of negative 32. I want you to come up here. I already did this one. The square root of 32 we know is 4 rad 2. So let's just apply that down here. So the square root of a negative 32 is going to be 4I rad 2. The square root of 32, already did it up above, is going to be 4 rad 2, which means the square root of negative 32, that's also negative, is going to be negative 4i rad 2. All right, so that's just working on where's our negative, how do we place that? So now we're going to work on simplifying roots. So for our first example, I'm going to give you the square root of 324. You should always put this in your calculator first and find out if it's a perfect square. So put 324 in your calculator, hit the square root button. And you should come up to 18. 18 should be your answer for this one. So it's a perfect square. That one was super easy. Number 2, we are taking the negative of the negative of negative 72. So we're taking negative, so it's negative 72. We're taking the square root of negative 72, and then that value is going to be negative. So here's what I'd like you to do. I think this is a little bit easier than breaking 72 down into a whole bunch of square roots, like up here. So rather than doing all of this for 72, what I like to do is like a factor tree. And so I just think of a pair. What's a pair of 72? My brain thinks of 8 and 9. Then what I do is I start to look for like perfect square numbers in here. And so you can already see that 9 is going to be a perfect square. So you could take the square root of 9 and it's going to give you 3. I'm going to keep going so that way I can just show you this tried and true way that will work 100% of the time. And it's where you're going to break this down into its prime factorization. So what that means is that all of these numbers at the end of the tree are prime factors. Do you remember what a prime factor is? A prime factor is a number that is divisible by 1 and itself, and that's it. There's no other number that can come into it or go into it. So here's what we're going to do. Keep in mind that a square, taking the square root of a number, is saying what number times itself will give you that number. So here what I do is I circle up my pairs. So I circle up my pairs because this is essentially like me taking the square root of 4, right? Like 2 times 2 is going to give me 4. Keep in mind where this 4 is located. It's underneath the radical, right? So the square root of 4 is going to be 2. So I'm pulling out that 2 to represent that pair. Here I have another pair. This again, remember what we're actually doing. This is like the square root of 3 times 3 right now, which is the square root of 9, and the square root of 9 is 3. So one of these also comes out to represent the pair. And when I say comes out, I'm talking about comes out from underneath the radical sign. And then I have this 2 that's left behind. It does not get paired up with anything. And so what I have now on the outside of my radical, I'm totally running out of space, so I'm moving it over here. I've got that negative that is this negative. I'm going to take 2 times 3 out here. So this is the ones that came out, which is going to be 6. How do I pull out the negative underneath the radical? It should give me an I. So I'm going to have negative 6i. What's left underneath the radical? Remember, what's left there is this 2. So we're going to have 6i square root of 2 when we're done with this, and that should make sense. Another way, just don't forget, you can check your answer. Go take the square root of 72. See what that is in your calculator as a decimal, and then go do 6 times the square root of 2, and you should get the same exact decimal just to check your work. All right, let's try another one. We're going to do the square root of negative 150. So break it up however you'd like. My brain looks at the fact that it's divisible by 10 because it ends in a 0. And then we're going to have 15. You can break it up however you'd like. You should try your own way and we should come up with the same answer. So here, maybe you guys want to break it up by 50s. That would be fast. So here, we're going to do 2 and 5, 3 and 5 when I'm breaking those up. All of these now are prime numbers at the end of this. And remember, I'm looking for my pairs. See how this one's different? This one, the pairs were right next to each other. It doesn't matter that they're not next to each other here. So I want you to think about this. This is essentially like me taking square root of 2 times the square root of 3 times the square root of 25. Is that going to get me back to 150? For sure, it definitely is. So what we're doing here is I've got this pair. It's going to come out. The 5 is going to represent that pair on the outside of my radical. So here I've got 5 on the outside of my radical. I've got a 2 that's left behind and a 3 that's left behind. Those are going to get multiplied together. So I've got a 6, and I'm still not done. I have this negative that's on the inside, so I need to put an I right here. So you've got 5I rad 6 for your answer. Oops, on this one. All right, let's try some more. You're gonna have to, like, the next day when we start working with quadratic formula, you're gonna have to be able to do these pretty quick. So that's why we're doing a lot of these examples. Let's try this one. So the next one, we're gonna have negative square root of 48 all over 8. So if we've got this one, I'm just gonna work with the numerator for a second. So the square root of 48, you could do 16 and 3, that would be fast. I have a feeling most of you are gonna think of like 6 and 8, so that's what I'm gonna do. 2 and 4, 2 and 2. I'm gonna circle up my prime numbers so none of them get forgotten. Now I'm gonna circle up my pairs. I've got a pair here. One's gonna come out to represent the pair. I've got another pair there. Another one's gonna come out to represent the pair. The 3 is left behind. So on the outside, I'm gonna have 2 times 2, which is 4. And underneath the radical, what's left? A 3. And then it's gonna go all over 8. Well, now you need to reduce. So right now we've got negative 4/8. This is gonna become a 1. That's gonna become a 2. So your final answer for this one is gonna be negative rad 3 over 2. And that's your final answer. Guess what? We're gonna try another one. Okay. Let's try this one. We've got square root of negative 27. That's gonna go all over 6. And try it. Try that one. See how you do on that one. So see what you get. And I am going to circle that to let me know that I gave it to you. Hopefully you're close to being done with that one. So our next one's gonna be negative square root of negative 24 all over 2. Here, again, I'm just gonna work with the numerator for a second. And I'm gonna do 24, I'm gonna break that down into 4 and 6, 2 and 2, 3 and 2. And I'm gonna circle up my pairs. One's gonna come out of the radical to represent the pair. These 2 get left behind and get multiplied underneath the radical. We also have a negative underneath the radical, so don't forget what that means we need to do. So I've got negative 2I square root of 6, because I'm multiplying these guys together. And then it's gonna go all over 2. Don't forget to reduce. So we're gonna cross off the 2's. I've had students before say, why can't I do 6 and 2? Why can't I reduce 6 over 2? You can't do that because it's not 6, right? It's square root of 6, and the square root of 6 is an irrational number. So it's gonna be somewhere around 2.5, right? So 2.5 is not the same as 2, which is why you can't reduce it anywhere in there. So our final answer is gonna be negative I square root of 6 for that one. I'm going to give you 2 more. Number 7, we've got, I'm going to have you guys try this one. We've got negative 450 all over 3. So I want you guys to try that one. And then I'm going to do one more with you. The last one I'm going to do with you is the square root of negative 68 all over 17. So I am going to work with the square root of 60, or yeah, the square root of 68 just for a second. I'm going to do it too. So sorry, I'm trying to adjust my iPad here. All right, so we're going to do 68 over here on the side. I'm going to take a 2 out, which is going to give me 34. And then I'm going to take another 2 out, and that's going to give me a 17. I'm going to pair up my 2's. 1 2 is going to come out to represent the pair. That 17 is going to get left behind underneath the radical. So then outside the radical, now I've got 2i because of this negative, square root of 17 all over 17. What can I reduce? Is there anything I can reduce here? And the answer is no. That's it. That's our answer. So that's it. We're done with roots for right now. So thanks for tuning in. Don't forget to do those other 2 on your own.